Hey folks, welcome to our weekly open source meetup. Well, weekly-ish, sometimes, we just don't make it. Life happens. We missed last week, I think, but we're back. Pretty much going strong since Hacktoberfest, where we decided, hey, let's do it once again next year, and it escalated a little bit. We're here each week to discuss various topics around open source, around developing software, operating stuff, just anything we think is interesting. And we find a lot of things interesting. So welcome to today's meetup. We'll be chatting about infrastructure as code. But before we start with that, I'll introduce myself. I'm Susanne Daniels. I'm one of the organizers of this meetup. Normally, I am a bit behind the scenes doing some producing stuff. I'm joined with Nick doing the producing stuff today, and Floor is in the chat moderating. Speaking of which, there's this chat box there on the website. And you can interact with us there during the meetup. But we also have a Discord channel. The link is up there somewhere. And feel free to join our Discord server, where some people working on open source projects hang around, attendees of previous meetups, speakers of previous meetups. So there's a lot of people there. Feel free to interact there and say hi. We like that. And we like it even better if you have this burning question you want to ask to the folks joining us today. Great. So there is also this code of conduct. You can read it here on our website. It's at Contributing.today. And somewhere in the top is the code of conduct link. In short, let's be kind to one another. Appreciate we're all here to learn and to contribute. And if you notice anything which is like iffy, please bring it up with one of the contact persons listed in the code of conduct. Now, you might have missed one of our previous meetups, which is totally fine. We get that. Luckily for you, we have recordings of nearly all meetups which have taken place in the past, and you can find them on our website as well. On topics like Python, Go, TypeScript, open source documentation, sponsoring open source software, various topics, very diverse. So check them out. Now, without further ado, let's start discussing infrastructure as code, and I'm joined by two brilliant people. The first one is April Edwards. April, I'm gonna officially congratulate you because April just became a senior cloud advocate at Microsoft. We happen to be colleagues, and I'm totally happy you're joining us. So, what are you focusing on as cloud advocate at Microsoft?
That's a great question. Well, I'm 3 days into my job role, and I'm starting to remember what my actual job title is now, because at Microsoft we have really weird naming conventions. But I'm under the DevOps team, under Steven Morawski. So mostly DevOps stuff. So anything from Azure DevOps, anything GitHub Action related, DevOps theories and practices, so methods and practices, and anything infrastructure as code. So because I have that ops background and that development background, we're bringing that together to do everything as we can. We can automate all the things, right? So I'll be focusing on infrastructure and code and DevOps primarily.
Yeah, we have that in common. You're at the right place then.
I am.
Welcome.
Thank you.
And I'm joined by Lee Briggs, who is developer advocate at Pulumi and calling in from Seattle. So, hi, Lee.
Hi, yeah, I have a very similar background to April. Before I turned into a developer advocate, very ops focused. So I've used many infrastructure as code tools in my career, and kind of transitioned into software developer and now infrastructure as code developer advocate. So it's been a great journey.
Yeah, great. So let's first start with some announcements being made the past few months. Actually, it is a great time for infrastructure as code. If you look at the steps being made and the progress being made in the various tooling. We will also be discussing today. Just thinking of Bicep, which released 0.4 last month, I believe. We have Pulumi 3.0 in April. And we have, well, the big announcement this week, of course, is Terraform. Finally, reaching 1.0. People were wondering. I think it's like a Duke Nukem Forever thing. Like, will it ever happen? Yes, it happened actually this week. So before we start, let's just take a look at the announcement. I have fast forwarded it a little bit, just to keep it a bit shorter. Apparently, a lot of infrastructure as code tooling people like to discuss all the history of all previous versions, which is great. So let's take a look.
And welcome everyone to HashiConf Europe. Terraform really begins in 2011. This is 3 years before we wrote any lines of code for Terraform. In 2011, CloudFormation was released by AWS, and I wrote a blog post praising it, but I felt that it fell a little short of what I wanted to see. I wanted to see something more generic for infrastructure as code, something that worked with more providers than just AWS.
And I also proposed that the only way to do this efficiently was probably open source. Fast forward to 2014, and no one had really addressed this challenge. HashiCorp was starting to hit this challenge in the real world, and so we decided to solve it ourselves, and we started writing the first version of Terraform. This first version of Terraform was released in the summer of 2014, and supported only AWS and DigitalOcean. We just wanted to showcase the initial functionality that we could support multiple providers, and really focus on that core feature set out of the gate.
We're excited to finally announce Terraform 1.0. 1.0 is a major milestone in delivering infrastructure as code, and we're focusing on interoperability, upgrades, and maintenance as the highlight things for 1.0 and beyond. In terms of interoperability, we've seen since version 0.12, every release after that has really focused on laying the foundation so that we could promise interoperability between releases. Up to this date, we know we've made breaking changes, we know we've made Terraform incompatible with other versions, and this is something we want to stop. So as of Terraform 1.0 and the 1.x series, any upgrades into Terraform 1.x from 1.0 will no longer require rewriting any existing code, and all 1.x configs will be backwards compatible. For upgrades, related to interoperability, all the 0.x upgrades typically had some sort of complex upgrade guide associated with it, but in the 1.0 series, all upgrades will be straightforward and effectively a drop-in.
So yeah, that's basically like the main points of the version 1.0 announcement. I thought it was quite funny because like we've waited so long for 1.0, and I was watching this conference and I was literally like, is it going to happen? And then like the suspense was like building building up a lot.
Have you actually used it, Suzanne? Have you actually used 1.0 yet?
No, I haven't yet. And I've taken a look at what has been happening, because I think I am one of the people who were at some point using this, and just like a few years back, it seemed like it took off, but then yet it didn't. And that was the moment like, okay, what is actually happening here, and like, should we continue this? or should we like explore other options there, or just like combining tools? So and I think that if you look at especially the efforts being made in like the past year specifically, somewhere like 1.5, 2 years back, it's just started to take off. I think that there might be some cloud providers involved there as well. But it really took off again, and like the development of the product, it just like it took off again. I don't know if you recognize that, but
yeah, we really did. I say Microsoft, because we've done a lot of contributing with it to the open source community, but also, so I you introduced me as being in this new role. Previously, I was in the engineering side. So I was in commercial software engineering, and we were using Terraform in every single customer project that I was engaged with. And then there were projects we used other things like ARM templates, Pulumi, but we had to make these decisions, what was right for the customer. We had to go where the customer is. And for a lot of our customers, it was Terraform, because it was easy to adopt and learn within an organization that didn't either have a lot of development background or just didn't have capacity for maybe a certain language. And that's a massive issue we've had. We've had all sorts of bugs we flagged in our engineering practices, and that's been put into the issues in GitHub with Terraform, and they've addressed it. They've been really good at addressing it. They're not only the community, but them themselves and Microsoft themselves. We have a lot of contributors to making these things right. So I think with each release, I would say 13 and 14 had a lot of things that we really dug out. We blogged about as engineering. I will self-admittedly promote myself and say I've blogged about some of the issues. I've promoted my colleagues. I've blogged about the issues, because there's something that everyone's done, and you think, oh, I must be the first person. Then you realize you're not the only person. So that's why we put it into our blogs. But I think 15 was a lot more stable, and there isn't a lot of difference from 0.15 to 1.0. So it'd be really interesting to see how 1.0 grows. But you hit the nail on the head. Every language, every infrastructure as code language that we go to embrace has limitations, and you just have to be aware of that going in. And I'll say this about Pulumi. It's awesome. It has limitations. So does Bicep. So does Terraform. You just have to pick which limitations are the lesser devil for your project.
Yeah, one of the things that make me happy, and I just stopped the announcement there. I think, like if you look at upgrading, that has brought us the challenges like in the past, stuff breaking, being not compatible with newer versions, no backwards compatibility. So those are really things like if you want to be serious with such a product, you just can't cope with having like these issues coming up when you want to upgrade.
It's maintaining it too. Like if a customer has embraced Terraform all throughout or on massive projects in their infrastructure, how do you upgrade to the next version? Then how do you deal with the breaking changes? And each time it was really, really painful for a lot of our customers. So they had to really make a decision when to upgrade and when to not. And actually, I had a gentleman the other day, not sure where he was located, created a pull request off my repo. It's like, I've updated your Terraform code for you. And I'm like, thank you, because I haven't maintained it because I've been on other projects. But I also forget that like that information is really valuable for people as a starter. But yeah, maintaining it's been really tough as well. And then, how do our customers feel? I say our customers, Microsoft's customers. So I think that's the thing, is maintaining it. So I'm really hoping 1.0 will be a really good platform for people to kind of like, right, we fixed all these issues. Now let's embrace this. And it's very enterprise ready, where it was enterprise ready before, but it's that next evolution. So that'll be really good to see and watch it.
Yeah. So Lee, well, you had this announcement like a few months back with your 3.0. Let's just take a look at the announcement, and then well, I'm curious on what's new and what's happening, and your take on infrastructure as code. But first, let's watch the fragment.
Hi, my name is Luke Hoban. I'm the CTO at Pulumi, and I'm really excited to be here today at Pulumi Up. Today, we're announcing the availability of Pulumi 3.0. Pulumi 3.0 is the next major version of Pulumi and the foundation for Pulumi's cloud engineering platform. Pulumi 3 builds on all of the work we've done since we launched Pulumi back in June of 2018, including the releases of Pulumi 1.0 and 2.0 over the last couple of years. Pulumi 3.0 includes dozens of new features and hundreds of improvements and fixes, both developed by the Pulumi core team and by the broad Pulumi open source ecosystem. Pulumi 3.0 provides industry-leading support for building, deploying, and managing cloud infrastructure and applications.
Yes, so that is a very brief introduction, but yes, so Lee, yeah, take me into the story of 3.0 and what's new and what's happening.
Yeah, I think the biggest announcement that we really had in our 3.0 launch was the general availability of what we call the automation API, which I sent the link over earlier. This is a new kind of thought process for infrastructure as code. And for those people who are watching that aren't really familiar with Pulumi's approach, our approach is to use what we call general purpose programming languages. So the application languages that you would use to build your application, you can also use them to build infrastructure in your cloud provider of choice. And what the automation API does as part of 3.0 is actually takes those languages outside of the constructs of the Pulumi command line interface and lets you build infrastructure provisioning mechanisms in whichever way you like. So you can build your own command line tools, you can build web applications, you can build developer portals, and this is all available. That we announced the general availability of that in our 3.0 launch, and that means it's available in all of our supported languages. So that's Python, the Node.js ecosystem, Go, and the .NET ecosystem, so C# and F#. So we're really excited about it. I have been building automation API examples now for around 6 months, and it's really powerful. It allows you to really change the way that you think about infrastructure as code, instead of kind of writing it and then having to run a command line tool in the CI pipeline is a great example of something that a lot of people generally tend to do. With the automation API, you can think about what your developers or your users actually want to do, and often they just want to go to a console and get a best practice version of their infrastructure. And with the automation API, you can do that. So yeah, it's really exciting.
Yeah, sounds like great developments happening there. So there's all these this stuff happening at this moment in the various tools, supporting more languages, bringing the tools to where the developers are and not like having them unifying them actually with this tool, because like in the past there were this the question always is, which tool do you want to use for what purpose? But if you have like a language barrier somewhere and people just have to choose a tool because their language is not supported, that can just make stuff overly complicated at the end of the day.
Yeah, the way that I like to frame it is, adopting cloud computing or going into Microsoft Azure or AWS has a learning curve. It has a barrier to entry. That even for myself, whose job it was to build things in cloud environments, you go to the Azure portal and there's all these hundreds of different services and you have no idea what they do and you have to learn those things. For us at Pulumi, our approach is that learning curve and that language barrier is already big enough. And if we can reduce that by allowing you to use languages that you're already familiar with, that you're already using in your application lifecycle, that just makes your life so much easier. You can kind of ramp up in those cloud environments as quickly as possible. A great example I like to use is, everybody has looked at YAML and understood YAML at some point in their time, at some point in their career. And then you look at something like a Kubernetes YAML manifest and you think, wow, I never knew there could be so many lines of YAML. That even that document that is supposed to be relatively easy to consume, you have to look up each field, you have to understand what they do, you have to kind of have a whole new learning process. And by using languages that are familiar to you in your software development lifecycle, we believe, and we've seen great impacts where our customers and our users really appreciate not having to have these, multiple things thrown at them.
I see April.
I agree. That's the biggest barrier to entry. And I think this is a double-edged sword. A lot of people look at cloud and think, oh my God, there's a ton of stuff to learn. What do I do? Like, and they're super overwhelmed. And then the other side of the sword is when people are moving to cloud, and when we engage with customers, they're going, I'm out of job, right? They all might think, I've been specializing in X, I won't be able to do that in the cloud, it's taking away my job. And that's not true. And we need that mindset of, yes, there's a lot to learn, but there's a place for everyone, and your role changes. And whether, whatever your coding background is or not, going into cloud, there's a lot of changes, but you need to lower that barrier to entry and take your people on that journey. And that's the hardest part of cloud, whether you're an AWS, GCP, or Azure, and they all have different naming conventions. So, what a AWS Lambda is an Azure Logic app, I believe. Yes. Like the naming schemes are completely different. So we need to lower that barrier to entry, and Lee's absolutely correct. And, I also deal a lot with ops people that are like, I don't know how to write code, and I'm not a developer. And I heard a great quote the other day that you are a developer if you tell the machine to do something for you, whether it's in PowerShell, Bash, or any kind of script. And we just have to find that way to take that and say, right, well, you are a developer now. Now time to make that into infrastructure as code. So that was probably the best way I had it kind of relayed to me that really hit home, because whether you're in ops or development, you're telling the machine to do something for you with some kind of tool. But yeah, that barrier to entry is really tough in the cloud, and we have to find a way to do that. And I don't think there's any one right way, which is why we're all here. But yeah, it's tough. It's tough for people learning and starting out in cloud, but there are tons of resources out there.
Yeah, I think the most important thing for, like, as somebody who, you mentioned, like, as somebody who, has come from a background who once upon a time never thought they would have the title software engineer. I actively avoided that title. I think the industry is changing around us. Once upon a time, I was a system administrator, and then I was a DevOps engineer, and then I was a platform engineer. I think from my perspective, one of the things that I would say is, if you are watching this and you have told yourself at some point in your life, I will never be a software engineer, I don't even want to be a software engineer. Infrastructure as code is software engineering. It's just a different mechanism of software engineering, and it's a highly skilled and highly sought after set of skills that people really, really need. I love the idea that people from a background of, like, who used to SSH into Linux boxes all the time, and now the people who are actively building out, complex multi-cloud architectures. It's just the journey that we're all going on together. And infrastructure as code gives you the repeatability to be able to say, I know how to do this over and over and over again. And that's the key word that I always use when I'm speaking to new users. It's about repeatability. You want to be able to do the thing that you did that works, and you want to do it over and over and over again. And any infrastructure as code tool will allow you to do that.
Yeah, and it is like, it might be scary, like to what you mentioned, and I recognize this. Like, okay, well, I'm a coder, I became sysadmin, and then suddenly I noticed that my whole work changed into coding again, but coding different things. And eventually, this is what happens, and that is that it doesn't matter if you are a network engineer. That is code, which you will be writing. And if you manage Linux boxes or Windows boxes, it's code. It is all code. And that is where essentially everybody gets involved with defining their infrastructure as code, and thus being a coder. And that is can both be scary, but it can also be like this great opportunity to do all those things you want to do. But I was just wondering, like, okay, somebody's watching, or maybe like in career or just starting out, and decided, okay, let's embrace this infrastructure as code thing. There's these many tools with many differences, and I think especially for people in large environments with different departments, with all their own tools, or even different customers with their own tools. So what is a good way to at least start learning those concepts? What are your experiences with that?
So I'm going to do a little bit of shameless self-promotion. So Channel 9 has great videos. We have the DevOps Lab. The reason why I promote it is because I did a video, Terraform in Azure. I think they're going to send the link across. And there's a series of those videos. And actually, if you go into the video, there's a link to my blog, which is azapril.dev. And I did the whole series in there. So really super simple Terraform basics. Another great resource is learn.microsoft.com, because Microsoft has done a fantastic job of doing a learning platform. So if you want to learn a language, you want to learn a technology in Azure or, Terraform, we have modules on that. And they're free. And they also give you a sandbox environment. So if you're sitting there going, well, I don't have an Azure subscription, I'm not giving someone my credit card because, yeah, I get that. It costs money. Learn.microsoft.com has that free sandbox environment. There are tons of videos through Channel 9 that Microsoft has about how to learn about these things. We, again, self-promotion here, did one on how to learn about ARM templates. I did one, I'll find the link to pop in a minute, but where to learn about ARM templates. We had a whole series, Azure Learning Series, that's just come out. I don't think all of it's out yet, but I'll find the link and set it in. But there's so many great resources, and they're free. Like, I remember having to pay for stuff and potentially download stuff illegally to get my learning materials. So having free resources is really great. And I'll hand it over to Lee to talk about Pulumi, and I'll get this link on the ARM template piece.
Yeah, I think just to kind of touch more generically on the point, like, if you are kind of starting out in the infrastructure as code world, the most important thing I would say is find an actual real world problem that you want to solve. And usually that means I want to host my own blog, or I want to, run this Minecraft server or something along those lines, something that's an actual real world problem. That certainly has always helped me when I'm trying to learn new concepts and new things. In terms of the actual Pulumi of it all, I run workshops every month. There's actually one tomorrow. If you are a Google Cloud viewer, I'm running an Introduction to Google Cloud tomorrow workshop, which is, an opportunity to get hands-on, and I guide you through the whole process of actually learning how to use Pulumi as an infrastructure as code tool. We have a lot of really great getting started documentation, which I think is really, really great. But for me, the most important thing is making sure that you are solving a problem that actually kind of resonates with you. I always, I have a nephew who I'm now he's a huge fan of Minecraft, and he loves playing Minecraft. I'm like, how would you like to learn how to run your own Minecraft server? And I'm introducing these concepts to him as he's going through it, and I can see that it really is starting to resonate with him. It's really important for me, at least in my learning journey, that I understand why I'm solving the problem, and it really helps it bed in when you're kind of doing the infrastructure as code stuff. And then I'll repeat the thing that I said earlier: repeatability, making sure that you do it over and over and over again. The 10,000 hours of practice thing. You become an expert in these things if you just keep doing it over and over again.
Yeah, and break stuff.
And break stuff, yes. I have written some horrible bash scripts in my time that have broken lots and lots of things. So, you end up learning really quickly when you break stuff. Not production though. Don't break production.
Yeah. Get a sandbox. Absolutely. But yeah, I think you're right, Lee. You have to have something that excites you. You can't just go out there and learn Terraform off the back or Pulumi. You need to find something. And anyone customers are starting out with infrastructure as code, they'll go, where do we start? And I say, find a project. Where I used to work a lot with customers is we had a customer problem. They had an application or an application stack that was sitting on-prem and needed to go to Azure. They didn't have the resources nor the knowledge. So my team was responsible for getting it there. And so we did a lot of transformation, app transformation, and it didn't matter what the end thing was. We had a project, and for the team to see that evolve, this is a pain point in the organization. It's a set focused project. They all had, vested interest into this project, and they were so excited to see even the first thing, like we spun up a virtual machine and the guys in the room were cheering. And, I'll say for myself and Suzanne and probably Lee, like when you spin up a single resource in Azure, you're kind of like, okay, we do that every day. But for a customer, that's awesome. And they're all vested in it. So they were super excited every time we started doing something with the code and doing something different and showing them new features. And, oh, but wait, it does this. So no matter what tool you're using, having that vested interest is really, really good.
Yeah. And so the other thing is getting started with infrastructure as code. Okay. But one of the challenges, at least I spot, is when people join a new company and they have to be onboarded. We do infrastructure as code with product X, Y, Z. So, what are your experiences in the pitfalls with using it broadly across a company, and how to onboard people with that?
I mean, my personal perspective is like any software development project, the people who have seen the most of it have most understanding of it. And I think we as human beings almost immediately want to refactor things and rewrite them so that we understand them. My personal, and I think this actually just came up as a question that just came in, really good testing mechanisms will allow you to feel real confidence in the changes that you're making. So when you're onboarding new people, if you have a good set of integration tests and a good set of actual, like, validation tests, people can then feel way more comfortable making those changes to your production infrastructure without worrying that you're going to cause a bunch of problems. And it's funny that the two things came up, like having guardrails is stuff that you can't do without infrastructure as code. Like if you are just clicking around in the Azure or the AWS or the Google Cloud Console and letting people do whatever they want, you really are creating problems for yourself to kind of create a Wild West environment. And so creating using infrastructure as code, doing repeatable things, and then a good set of tests helps people move into your company and feel confidence in the changes that they're making.
April, do you have
I agree. So I think when we talk about testing, and again, if you work in ops or even in development, any environment, and sometimes your testing environment is not like production. So you're not testing like for like. And I think I've seen a lot of organizations, and I've seen it in real life, like myself or my colleagues, and not Microsoft, but former roles, where we didn't test something, we just did it. We pushed a button. So when you start doing infrastructure as code, you have to start thinking about testing. And this plays into the DevOps story. When customers are like, how do we start embracing DevOps? So this goes hand in hand with infrastructure as code. And that's why these are like a great, married couple. If you're going to start writing your infrastructure as code, looking at testing, because we call this shifting left. So we start testing our code early. The other thing we do before we even test our code, we start looking at ways to write our code better, because before we get to that test, let's write it better. So using your tooling on, your development machine, whether you're using Visual Studio Code and you're using an extension for Terraform or Pulumi, or if you're writing Pulumi in a certain language like Golang, you have the Golang extensions in so it can read and pick up any formatting issues. There's also great tools that you can use, like linters for both Terraform and Bicep. And excuse me, Lee, I don't know Pulumi as well, but there are linting tools built in. So that's like looking at your code before you officially test it. Then when you push that code up to, your repository or running it in a pipeline, whatever you want to do, this is the DevOps story. You want to run and test that before you even deploy it to your sandbox. So for testing Bicep, the tests are coming soon. There is some testing capability. There's not a great deal just yet. I know it's on the roadmap. It's been discussed with the product team. But what they do have is a visualizer, which is really cool. So it's not quite testing, but you can deploy the Bicep code. And then in 0.4 that just released about a week ago, you can visualize what you're doing. And for me, I'm a visual person. So actually, I really like that. But you can actually throw your code into like an Azure DevOps pipeline or a GitHub action and run tests in there. Terraform has testing as well. So they use something called, you can write your own test where there's Terra test, which is written in Golang to test against the Terraform code. So learning about testing is really important because, you don't want to just throw something out there into production. And it ties into that DevOps story of shifting left and saying, right, we're going to write our infrastructure as code. We're going to do this the right way. We're going to put in our security. We're going to put in our testing, and everything's going to be squared away from the get-go versus kind of doing everything as an afterthought.
Yeah, I totally agree. Like the shifting left mechanism, like the mindset, is really important for these kind of things. Kind of doing things right early saves you a lot of pain and headaches down the road. Again, to be a little bit more of this on the sales side of things with a Pulumi, because you're using the standard programming languages that you use in your application development lifecycle, you just use the testing frameworks that you're already used to. So if you're writing Pulumi code in JavaScript or TypeScript, you would just use something like Jest. And we have a really great unit testing guide that will show you that you can feel real confidence in the changes that you're making because you are using these kind of standard off-the-shelf languages. And one of the things that I personally experienced as as an ops person, I actually really struggled with the idea of writing unit tests. It was something that I was YOLOing things into production my whole career. So I really did struggle with this idea of testing. And one of the things that I have learned in my kind of, just over a year at Pulumi is that it's not really, it's not that difficult to be able to kind of level up your skills and start to learn these concepts. Essentially, what you're doing is applying things from that software developers by trade are already doing and applying them to your infrastructure, and that can only really give you a lot of happiness down the road, to feel comfortable in the changes that you're making.
So talking about shifting things left, security are well, most of the time the last topic which comes by. So what do you see happening in this space around security, and how do you shift that left, and what do you see happening there, and do you have any great insights to share?
If you don't mind me going first there, April, one thing that I have noticed is that all of the major infrastructure as code tools, whether it be us at Pulumi, even in Kubernetes YAML, there has been a big push towards policy and making sure that with infrastructure as code, you cannot make changes that you're not allowed to make. And that's something that I've seen really start to become a consideration. We work with several large companies, and this is a really big consideration point for them. I know that HashiCorp has Sentinel as well, which is a policy framework that allows you to make sure that the changes you're making are within the boundaries of what is acceptable. We've all heard about horror stories about large banks who shall remain nameless being breached because of misconfigurations in security policy. Again, this is another thing that infrastructure as code gives you that you can't really have if you're doing things manually. The ability to put these guardrails in early on in your kind of life cycle to make sure that the changes that you're making aren't going to accidentally expose something that you wouldn't want to have exposed to the world. So policy for me is the thing that is really starting to kind of come up as a as a consideration point for a lot of organizations.
I agree with policy. There's definitely guardrails, I think, but we need to start a little bit earlier. So when I'm talking to customers directly about security, we start from day one. So where's day one? Where's the starting point? It's the developer space. So you're person, so you're human. You're cloning your code. As soon as you clone that code from that source code repository, your security needs to begin there on the developer machine. Now, this can go kind of twofold. We talk about developer velocity at Microsoft. We promote it. We talk about, running on trusting your development team and enabling them. Yet I've also worked with organizations that lock down the developer machines so heavily they can't use proper tooling and they can't access anything. And that takes away that trust, that velocity that the developers need. So, tooling doesn't solve all the DevOps problems, but it's a good, it's something important to focus on when you start. So, how you're cloning that code, where's your code going to? Is it coming from a repository? Is it public? Is it not? Where does the data sit? So when you clone that to your developer machine, how are they writing their code? Are they using VS Code on their machine? Are they using GitHub code spaces, which is a secure environment? So where are they developing their code? And then using those tools built in and baked into the platform in their source repos, doing that scanning in the repo before it even goes into Azure or into GCP or AWS. And, as soon as you deploy that code, you've already sent that off. So we need to look, from that developer point of view, how are you enabling your developers to write this code? And this is where the tooling can really, really help, because I think, honestly, we've all made mistakes. I've mistyped something. I've put in a wrong number, a wrong digit, a letter. And I've seen people put in passwords in plain text documents, and even things like GitHub repos where they can do, secret scanning and pick these things up and flag it to the admin. There are so many great tools out there that start day one that we really encourage our customers to use. So whenever we start a customer project, we are focused on, right, we have a process and we want to, engage the people and teach them new things, but we need to look at the tooling to enable us as well. So we look day one with the developers when we're starting to talk about security, and it's making a massive difference. But then, yes, then there's guardrails as well once that deployment goes through. Otherwise, it does turn into the wild, wild west. And then you have customers screaming and flailing and going, we have 90, subscriptions. What do we do? So,
and this makes it extra difficult, because when you are on that cloud platform of the cloud provider, you there have tooling for policies, security tooling. This is where infrastructure was already complicated to abstract. Well, there comes a whole new set of things to worry about, which you can maybe test on beforehand. You can catch like the things going out of those boundaries, but yeah, eventually you have that part as well. So with the added complexity on the cloud providers, and especially if you're multi-cloud, that is like, I think, super challenging. I'm really interested in how this will evolve the products as well, because I think that like each product has their advantages, but this is really something keeping people awake. I think
it does, and I think the big thing too is involving that security team early. And Lee touched on it before. With infrastructure as code, you're writing that security into your code from day one, and that's that shift left mindset. So when people are like, "Well, how do I do that?" Well, bring in your security team. What are their requirements? Because they will tell you what they need, and you don't want to write your code, go through all your testing, pull all your hair out, or go gray as I tend to do, and then the security team flags it and goes, "Can't have it. It's not secure." So day one, bring them in. And also it makes them feel like it gives them the warm fuzzies, because nobody likes that security conversation down the road, or that, pushing the project over its edge, and that goes against the DevOps principles, right? So, but Lee totally hit the nail on the head with the guardrails. So get the security people involved early, and that makes a massive difference.
Yeah, people invite people to the party.
Exactly. We're going to have a code party. Everyone's welcome.
Yes, better than day drinking alone. So, okay. Well, I think we have been talking for quite a while now. I know Lee has something to show off.
Yes, I do. I do indeed. Yes, absolutely. I put a demo together. I got a couple things to show off. If that is not too much, too much to kind of do, let me just rearrange my screens a little bit here. So I've got an example Pulumi program. Let me share screen. I want to share this screen. Nope, that's not what I want. There we go. So I've got an example Pulumi program here. I've chosen Python today just because I felt like doing Python. One of the great things about Pulumi, working at Pulumi for me, is that I get to consistently look up how to do an if statement in 4 different languages. Because apparently, if you're changing languages all the time, you never really remember how to do it properly. So this is just an example Pulumi program of Azure native, and as I said, I've chosen Python today. And what I thought we would do is just very quickly look how that would look to deploy something in Azure ACI. So we have the Azure native provider, and what that means is that we generate all of the actual resources that we deploy with Pulumi directly from the Microsoft APIs for Azure. So when Microsoft releases a new feature, we get that feature as soon as it is published to the API. And there was some big announcements a few weeks ago about new Azure resources, and we had support for it on day one, which I think is awesome. And I really love to look at the API definition updates and see what's coming down the pipeline for Microsoft Azure as a platform. But we have this ability to, very quickly create, add the support for the new resources. So here's an example of me just creating a resource group. And if you are familiar with Python, this probably looks pretty familiar to you. I'm just creating a variable and then, creating a resource group. And then if I want to create a container, group, I think it's called in Azure, I just use the standard Python syntax to create a container group. So container group, and I want to call it example. And then I want to flesh this out so that it has all of the actual definitions that we need. So if you've used ARM templates, this will look pretty familiar. So we need to set an OS type, and you'll see, because I'm using standard Python and standard VS Code, it's giving me autocomplete. So I'm getting all of that kind of like helper hints to actually make sure that I'm getting all of the help that I need. And then I would do something like this, and I have this reference example here because I'm not talented enough to do this on the fly. But this is generally what it ends up looking like. And in order to kind of save us some time, what I'll do is copy my example to show you what it looks like when it's finished. So this is kind of what it would look like to define something in ACI, to deploy something to ACI. You can see that it's basically, if you've used ARM templates, it's very similar to the ARM kind of API, and it should make a lot of sense to you. And so this would deploy it would deploy this particular image to Microsoft ACI with 30 lines of code, which is really awesome, and it's using the language that I'm already familiar with in Python. So that's one way of kind of doing infrastructure as code with Pulumi. But I already mentioned earlier in our 3.0 launch that there is the automation API. So if you are familiar defining infrastructure in this way, that's awesome. You can write in whatever language that you like, whether it be Python, Go, or the Node.js ecosystem, or .NET. But sometimes you don't want to write all of the code over and over and over again, but you want to have the same repeatability. So the automation API, which is this is an example written in Go. I've written a small command line tool that actually allows you to kind of do an infrastructure as code deployment using my own custom built command line tool. So this is just standard Go code, a command line interface written with Cobra and Python, Cobra and Viper. And I've embedded my Pulumi program into this command line tool, which I call Ploy. And this allows me to deploy things without actually having to write a single line of code at all. So I've built this command line tool called Ploy, and what it will do is it will take this Docker file that I have here that I've built, and it will deploy it to a Kubernetes cluster and upload it to an image repository, and I don't have to write a single line of code. So it looks a little bit like this, and I've obviously misspelled that. So the command line tool that I've built is Ploy, and again, this has a Pulumi program embedded into the command line tool, so I don't have to run Pulumi up. I can just run Ploy up. And we'll wait a second, and you can see it's building me a Docker image, and it's creating me an image repository in Amazon AWS, pushing that Docker image to it, and then it's going to deploy a Kubernetes service. So I'm still doing infrastructure as code, but I haven't had to write a single line of code. And this is what I was talking about when I kind of introduced Pulumi 3.0, being able to build user interfaces for your users in ways that kind of make sense to them, I think is a super powerful mechanism for infrastructure code. And we've seen this automation API used in a variety of different ways. We've seen people building internal developer platforms that allow you to do kind of best practice deployments without actually having to write a single line of code as an end user or a consumer. It's really, really powerful. So that's just a nice quick demo, and you can see my services deployed in Amazon AWS, and I can do this over and over and over again. The repeatability that I get with infrastructure as code is still there, but my end users don't have to actually do this on over and over and over again. So that was just a quick demo. There's lots of exciting stuff around this. If you if you're interested in this kind of mechanism of infrastructure code, but you of course also have the standard Python, TypeScript, and .NET mechanisms as well.
Great, thank you. We love demos, don't we? So we are back. So there was also another thing happening. I say last month because I don't know, the past year everything feels like ages, but it's only been a few days, I think. Yeah, you got me there. So Bicep released a new version as well. I know April has probably something to share about that as well. But before we do, let's take a brief look at the announcement.
Okay, so a little bit of context on where we are. If you've been with the project since its inception back in, I think September is when we made the repo public with our 0.1 release. 0.1 and 0.2 were like experimental With 0.4, what we're launching today is our first, post-production release. Leading up to our v0.3 release, obviously that was a pretty intense release. There was a lot of things coming in at the last minute to make sure that we had parity and the features that we needed. But there was a growing backlog of kind of like bugs and stability things that we wanted to focus on. And so we spent a lot of our energy on just fixing bugs, making sure that Bicep was as stable as it can be, in addition to some new features that we're excited to share with you. So the features that Marcus will demo in a little bit are really focused on like speeding up the inner loop of your Bicep development lifecycle. So there's really cool features like snippets and linting that will help you in context while you're authoring so that you get a higher quality Bicep file faster.
And that is the new kit on the block, celebrating 0.4. Curious to see when will version 1.0 become real. So April, can you share something around Bicep and the latest developments there?
Sure. So I'm going to share my screen as well. I prepared nothing because I'm doing well today. So
that's fine.
You know me, I like to DevOps my life. We're fine. True story. So hopefully we get this up. Cool. So this is the GitHub repo right here for Bicep. Hop to it, github.com/azure/bicep. It has all the new features. It's a great place to get started. I am literally cloning the repo as we speak. So might be able to pull into that a little bit. I don't have the latest. So it does go through the announcement from Brendan Burns, some cool stuff in it. The two things that I want to really highlight are, actually there's going to be three things. One is the visualizer. The visualizer is awesome. So anytime you're deploying anything like Terraform, anything, it's good to have an output. So when you write the ARM template and the visualizer's in that repo, if you want to pull it out, you can actually see what resources you have and you can move them around. I know that they want to take this so you can export this into like a JPEG or a PNG and put this into your documentation for a customer or for yourself, but you can see actually what connection is from what VM or what NIC or whatever it is you're using a public IP. So here we can see that we can see all these dependencies and you can actually move them around when you want to do that, which is really cool. So having that visualizer is great. It was available with ARM templates. My friend and colleague, Ben Coleman, really kicked that off and really gave that visual aspect, which was great because a lot of customers were asking for it. The other great thing about Bicep is we have baked in actions in GitHub Actions. So you want to start automating things, super easy. You can clone the GitHub, the Bicep repository and start creating some actions. Think about something that you want to automate. People always ask, what do I automate? And it's great to automate everything, but we can't always do that. And sometimes it isn't always productive. Now, we always say, yeah, automate all the things, but there might be limitations to that. Some things may not automate, but look into the actions. You can do some really cool stuff. You can do individual files, but it's all baked in and it's fully supported. So the visualizer is probably one of the cool things that, isn't super code heavy, but is cool. And a lot of people like it, especially for documentation. So if you're starting to create some infrastructure as code, want an output, great. You want to start automating things, going to GitHub Actions, and they're all baked in. Bicep also has baked in jobs for Azure DevOps as well. So you can go into an Azure DevOps pipeline in the YAML, go into the marketplace and get the tasks out for Bicep. So you want to start automating things, build some pipelines. You've written your infrastructure as code. You can deploy it through an Azure DevOps pipeline. And I will say this, Terraform also has this capability within Azure DevOps and GitHub Actions, but we're going to focus on Bicep a little bit. And there are Bicep tasks built into the command line. And you can also get this for Visual Studio Code. So you can get the linting capability in there, which is really great. The linting capability that they've put into Bicep for VS Code is really, really good. It's a great developer tool as well. And they're putting out new services all the time for it. So the roadmap is great. It is public. You can have a look at it. and there you go. And I think Bicep, again, similar to Pulumi. Pulumi has day one support. We have day zero. Well, we call it day zero support for Bicep, so that whenever a new Azure resource is deployed, you have support in Bicep, which is really, really important. So that's, day zero. As soon as we announce a new product, boom, you can deploy it. So that, that's always good to have, because, if something comes out, someone wants to try it. Having that capability is great. So those are the biggest updates in 0.4. Yeah. So Suzanne, any questions, comments, thoughts on that?
Yeah, I think this is really maturing, and I think that is a good thing. Though what I wonder, and I think a lot of people wonder this, and that is, okay, now it's dazzling. I know I want to do something with infrastructure as code, or maybe I already do infrastructure as code, but I'm like discovering and looking at the different tooling and thinking, okay, what is where I put my bets on? So how do all these tools compare to one another, and which one does one have to choose, and how do you make the choice?
I know what Lee's going to say.
Yeah, you should choose Pulumi. Absolutely.
Okay.
But honestly, the real answer is you should choose the tool that suits and fits your workflow and your organization. I think April said this at the start. All of these different tools have different trade-offs, and there is no the only magic bullet available is Pulumi. But if you don't like that magic bullet, then there are other magic bullets. There are other things that you can consider. You just choose the thing that makes sense to you. I think that the tool that we've built is fantastic. But for me, all that really matters is if you're getting repeatability in your deployments, and you're getting all of the great things that we've already talked about around testing and feeling good about the things that you're changing in your environments, then any infrastructure as code is better than no infrastructure as code, as far as I can tell.
Yeah, I tend to agree with that. Rather to just get started and have a tool which might not fit everything, tick every box you want. Like we just touched up on a few topics, right? And there's differences between the tooling, but one tooling is great at the thing you really need, and maybe not that good yet at the thing you might need, but not that hard, or you can work around it by using and mixing and matching different pieces of tooling, or it is maybe a dirty word nowadays, but adding some scripts here and there might make sure.
You cannot beat the timing of a well-defined bash script. Like, I mean, there's always
you can with PowerShell, actually.
Well, maybe. I mean, yes, any kind of scripting language, I feel like you can't be too far away from them. And one thing that I think is a really interesting space is, we have a bunch of configuration management tools, which we haven't really talked about, but are totally valid ideas of infrastructure as code. So at the operating system layer, when you are launching your virtual machines, you usually still need to do a bunch of stuff at that operating system layer. I think that space is ripe for innovation. I was using configuration management tools like Puppet and Chef 10 years ago. And I think that, there is this kind of idea that, with containers and serverless and all that kind of stuff, that those tools aren't really needed. And I have reached for bash scripts several times in the last week. And so I'm really, I'm excited to see what happens in that space once we all kind of get over running Docker containers. We're going to have to have some innovation in that space at some point, I would say.
So we should really watch the chefs and the puppets and
and I think there's so many options, and everyone's competing for the market. And when people ask what tool to use, if you want to be bound to one cloud, and no one is, like, no one's in one cloud. Well, I take that back. Someone is, but not many. Most of my customers are hybrid, and they could be in multi-clouds, whether that's on-prem, a private hosted cloud, or AWS, GCP. They're all hybrid. So, when you start looking at tools like CloudFormation or Bicep, they're native to that cloud platform. So that's great because there's advantages to that, but there's disadvantages. And then you start looking at Terraform, which is multi-cloud, but you got to change your scripts. And I actually saw a question in the chat when people were talking about how do you manage that data in that infrastructure as code environment, and how do you automate things, and are there guidelines? So that helps determine which products you use. And Terraform has a state file. So you have this file that contains all the data for what you're deploying, and you don't want to put that in a public repository. Step one, don't do that. But that state file lets you maintain that state. So when you delete that state file, you can destroy those resources. There's a lot of benefits to that. There's also some cons. And I don't want to get into that too much today because that's a long list and it's a big comparative analysis. But ARM doesn't have that state that you have to maintain, which is a benefit, but then also a con. And I think off the back of this, with the release of Bicep, the really great presence of Pulumi and Terraform 1.0, I'm going to start a series with a colleague. We actually just talked about this today, comparing the three and do it into a series of right, I want to deploy a container because Lee loves containers. And I want to do it with Pulumi, and I want to do this in Golang. And then maybe I'm going to deploy a container with Bicep, and then I'm going to deploy a container with Terraform. So we are going to start a blog series to pull out all the good, bad, and the ugly. Because I think the reality is I'm sure there are some downsides to Pulumi. I don't know any yet. But everything seems pretty baked in, pretty tidy. Terraform has some downsides, has some great positives, Bicep, both, and they're all growing products. So the space is really, really growing. And then I see another question about whatever happened to PowerShell DSC. It's still here. It's still around. I use DSC quite a bit actually for desired state. So I use my Terraform, or you could use ARM, but I'm going to use Terraform in this example. Deploy my environment, manage the infrastructure, the nuts and bolts, right? My virtual machines, my web apps, my infrastructure, and then I use desired state to manage the state on those machines. So I'll give you an example. We had a customer that had a single box sitting under a desk that managed a massive platform that they relied in their organization, and it was a single point of failure. We migrated that to the cloud. We put in a virtual machine scale set, but there was a dependency upon two VMs in that scale set. One had to be a Linux box and one had to be a Windows box. And the way that the production system ran, they had to be to the T, tied in together. And if they lost that state, you had to blow the whole system away. So we use DSC to maintain the state both on the Linux side and the Windows side. So DSC is still there. That's kind of like that further step in with infrastructure as code, and maintaining the state of your environment. That what's the OS look like? What's the patching level? The things that I hate talking about. So I'm like, go serverless, go platform as a service where possible. But DSC is required when you have virtual machine scale sets, etc.
We just got a great question from Flaw, which I'd like to address, because you also mentioned growth as well, like the growth of this industry. We've talked mainly about cloud, especially with infrastructure as code. In my previous role, I actually worked for a cloud costing company, or a company that actually tracks IT spend. And the question is are we at the golden age of infrastructure as code? Well, I was really, really surprised to see when we kind of did an industry analysis that the amount of money, the amount of budget that the world budgets for IT expenditure, less than 20% of it is actually currently used on cloud providers. There is a lot of growth here. There's a lot more to come in this space. And it might feel for somebody who's working in these kind of cloud environments day to day that the entire space is saturated. Like every job post that I see right now is infrastructure as code, all the different cloud providers, but we have not even, we're at the tip of the iceberg, and there's a whole lot of iceberg to go. So I think that we're going to see some really, really big innovations in this space over the next 5 to 10 years. Things like Kubernetes and containers are currently, the in vogue way of doing things, and they have been really, really successful. Is it the case that we'll be doing the things the same way in 5 years from now? That seems unlikely. There's going to be some huge innovations here. What I will, hang my hat on is that in 5 years' time, we'll still be talking about infrastructure as code. Like that isn't going anywhere. This is the way that I think people want to do things. All that will change is what we're actually doing with that infrastructure as code, rather than the actual practice of infrastructure as code itself.
And I think the biggest issue that I see with customers, and Lee, you probably see this as well, is when they're talking about whatever product they want to use, whether it's Pulumi or Terraform or Bicep, they want that 5 to 10 year plan. And I have to go to a customer and say, you cannot have a 5-year plan anymore. We still see customers with a 10-year contract with their data center provider. And like, oh yeah, we're locked in for 10 years. And I'm like, what light bulb signed a 10-year data center contract? Because Tech doesn't work that way. And that's inane to me. And they're locked into like a certain amount of spend and all this stuff. And it's just, that makes, that ties everyone's hands. But you can still do IaC and cool stuff with that. But no, we're not saturated, and we are going to change in 5 years. And I think, when we talk about infrastructure as code, we also have to think DevOps. We're going to go back to DevOps again. We need to be agile and say, yeah, we've deployed this in Terraform version 1.0. Well, 1.2 has come out, or maybe they'll get 2.0 out. Who knows? We have to be ready to adapt, but we have to be able to transform our code and use those great practices to get us there. So this is why DevOps and infrastructure as code go hand in hand. We can't just think, yeah, I've deployed this with Pulumi. It'll be fine in 10 years. Absolutely not. It won't be the same in 10 years. It won't be the same in probably 6 months to a year even.
It's kind of hard to think about this. 5 years ago, I was still racking and stacking servers in data centers. The idea that we would all be deploying things in cloud providers just seemed completely, like a pipe dream. And here we are 5 years later, and the idea of going to a data center and racking a server just sounds like something I will never do again. I think that really kind of emphasizes April's point. Think about what you were doing 5 years ago in your role. What were you doing on a day-to-day basis? It's very, very unlikely that in 5 years from now we'll be doing it the same way. But I bet you that the infrastructure as code practices that we're learning right now, they will still apply. The technology changes, the practices don't really change. Even with DevOps, like DevOps was this this incredible movement, and when you really break it down to what it actually is, we all just started talking to each other about the best way to do things. The technology changed a lot, the practices just stayed the way they were, and I think that kind of gives me some comfort that the things that you're learning now will always be applicable, and hopefully it gives us all great job security.
Yeah, and if you're watching this and you are racking up servers, ask yourself, is this what you want to do in 5 years still?
Somebody still has to rack the servers. Azure is a bunch of servers at the end of the day, right? It's still a practice that I think everybody needs to know and appreciate. I just think that we like my previous role were a SaaS tool, and we kind of asked ourselves the question, why are we doing this? Is not what we should be doing with our time, and that made a lot of sense at the time.
Okay, so let's take a brief look ahead. What do you see happening in this space for, well, let's say we can't predict 5 years, but what do you hope that will be happening in the next 1 to 2 years? I heard a revival of puppets.
We can fight over it. Lee, do you want to go?
Yeah, I think that we are going to see a lot more increase in serverless mechanisms. So one thing that would surprise me, and I was completely wrong about, is that compute has become commoditized. We no longer actually look at compute as something that and what I mean by compute is virtual machines, data center servers, or something along those lines. That is being provided by Microsoft, by Amazon, by Google, and people don't really want to manage that. And my prediction over the next kind of 3 years is that we will see further steps. People will no longer want to spin up AKS clusters as an example of that. I don't think that is going to be a practice which will continue over time, because management overhead slows everybody down. So I think we'll see a big increase in logic apps and things like ACI and those kind of things that allow you to just get your app running. I built a Pulumi library recently called Run My Damn Container, which is really what everybody wants to do. So that's my prediction. The kind of more bold prediction is that I think we will see a niche area of IT, and we've seen some of this already with companies like Oxide. We will see a niche type of provider that will allow us to buy hardware that is commoditized. So you'll get a whole rack and a whole set of servers, and I don't think this is necessarily going to take over, but I do think there will be a niche set of customers who really still want to maintain that control over their own environment. And we've seen a lot of this with things like, running extending Azure into your data center, which sounds really great for those people signing 10-year contracts. They have all this data center space. I think we're going to see an uptick in that as well. So we'll see two ends of the spectrum. One, which is serverless, kind of, I don't want to touch any infrastructure. And then I want to touch the infrastructure, but I want all of the great experience that I get from my cloud provider, but I want it in my premises. And I think that's the way it will probably divide. Could be completely wrong. I've been wrong before, but that's my guess.
Yeah, I think I agree with you, Lee. I think there's a lot of like that edge compute. We see a lot with Azure Stack, et cetera. People in remote locations doing things they couldn't do before. I completely agree on the serverless front. Whenever I work with customers, we're like, right, what can we do to not have virtual machines and then use things like serverless to enhance something? I just came off a customer project where we used logic apps and functions to do an entire workflow instead of building apps. And it cost like $14 a month to run the thing. Now, we tacked on a Cosmos database and some other things to enhance the product, but 14 pounds a month to let just sit there and go idle versus thousands and thousands of pounds is massive. I think we're going to see a lot in the AI and ML space. We're seeing a lot now with customers leveraging that in a lot of the products. I actually just got off a call today with a customer that is doing something really cool. They're like, but I want something else to do it for me. And it's adding that enhancement, that intelligence to what you're already doing and delivering that better service, that better value to your customer. We talk about value a lot when we're delivering software or applications, infrastructure as code. What value are we delivering? That AI ML piece, we're going to see a lot of intelligence built in. We already see it in like VS Code with IntelliSense, being able to do code completion and writing better code. Our code quality is going up. Then that's going to go into the cloud providers and go, right, you've deployed this thing. Now we add some intelligence on top of it to do X for you. I think we're going to see a lot more automated deployments and intelligence around the cloud in general and in the products.
Great. And well, this is all being recorded, so let's save that one.
In 2 years.
In 2 years. Yes, that's the best. I think we can do a special on that by then. So let's just handle some of the questions which are being asked in the chat. If you have a question, just throw them in the chat because we're going through them. So one of the questions is, do you typically see all stakeholders contribute to the infrastructure as code, like IT pros, the security people, DBAs, or rather pass on their requirements to the developers?
I think we kind of touched on this a little bit, but I like my personal perspective is if you're throwing anything over the wall to any part of your organization, that's just going to create friction. I think April brought up shift left really, really early, and I'm so glad that happened, because this kind of like mentality of, well, this is code, so the developers own it, or like, because it's code, the developers have to take care of it. Like, I think those days are behind us, really. I think everybody in your organization needs to be collaborative in solving this problem. So your infrastructure as code should be shared between everybody. Your DBAs, your ops people, your software engineers, security should be involved. Like, in my opinion, that's how you end up being productive. And that's how you end up, and it makes your life harder because it means everybody has to be a little bit more general in their day-to-day roles. But ultimately, it creates this sense of like, one purpose and all going in the same direction. I don't know what you think about that, April, but like in my experience working in the industry for 15 years now, every single environment that I've ever worked in where you've had that mentality of this is your responsibility and I'm not going to deal with it, just it always ends up in a painful situation.
Yeah, and it's anti-DevOps. So we have this definition of DevOps that we address at Microsoft, but we talk about the people, the process, and the products. So those three things. DevOps is not one of those; it's all three in combination, and we're delivering value off the back of that. So I'm going to address the people thing because that's part of the question. So the question was asked. Well, we have DBAs and we have IT pros. So my previous title was senior software engineer. That doesn't tell you that what I specialized in technically. I was an engineer. Microsoft made the shift from horizontal roles to vertical roles. So as an engineer, I'm responsible for the entire feature stack. So if I'm taking on a feature, I need to know everything that affects. So it doesn't matter if I have a database background or whatever. I'm going vertical. So I'm like, right, so there's a database involved. I have this infrastructure piece that maybe has some virtual machines or some web apps. Oh, and then over here, I have a UX layer or UI layer. I'm responsible to know from all that. So from the inception of the idea all the way to production, the engineer owns that and the team owns that. So like you said, Lee, it creates ownership in the team. So I'm no longer just a specialist at X. We break down those silos in the organization. We bring everyone together. Everyone owns something. And yeah, it means there's a lot to learn, but that's why, people aren't going to lose their jobs. And, we got into tech because it's fun and exciting. So we need to learn to go, right, well, I'm a DBA and I've written this thing. How does this affect something else I've done? You just don't focus on the data anymore. You focus on all the other aspects that you touch because these systems are interlocked. And that's how we see a lot of customers going from on-prem to the cloud going, well, we have all these silos. Oh, let's go talk to the database team. And these teams never spoke and they're always angry. Each of these teams have different KPIs. They're not goal-driven together. So we start breaking down those barriers. Everyone wants the same thing, and that's to be successful versus having these fights all the time. So, everyone needs to be involved with the infrastructure as code. So, you might have someone on the team that it specializes in whatever, and you have these very vertical teams. They might not be actually deploying the code, but they need to know how it affects their, the intertwinedness as well. So, but yeah, everyone should be involved. Absolutely. Break down those silos, get everyone together, one big happy family. You don't have to change everyone's job title. But their role in the team is super important.
Yeah, I just want to kind of accent that as well. Like, I've worked in environments where the interpretation of DevOps was, developers doing operations or operations doing development. And I really like what April said there about kind of your responsibilities. Your job title isn't changing, and your ownership and your responsibility and your expertise becomes more important. And what I mean by that is, I think it's really important in these kind of, fast-moving DevOps kind of, DevOps adoption environments. And what I think is really important is leaning on the expertise of people who are, good at a particular skill set. I like to think that I'm pretty good with most of the different cloud providers, but I also know that I'm not going to build a very nice UI. I'm not going to build a very good UX in JavaScript, for example. Those two pieces of expertise can combine to create something awesome. And I think it's really important, even if you do own the actual end product together, making sure that there are areas of responsibility that, people more heavily lean on. Like, hey, April's the person that we go to when we need to know how to do X, and Suzanne is the person that we go to when we need to know how to do Y. That is my experience of what creates a really, really great team. And I think to bring it back to infrastructure as code, one of the great things about infrastructure and code kind of coming together is that you can create really, really well-defined infrastructure and also pretty code that actually works every single time. By having these two pieces of expertise, system administrator type people, and then, software developer type people, bringing them together, I think, it really creates much better end products.
Yeah, and I think that is really spot on. If you have everybody involved with the code, with deploying the infrastructure, with deploying the applications, everybody working together, then your operation of your application or your platform, it will be like ACE. It will be better.
And you've got to bring some humility to the equation as well. Like, I can't go into any environment and think I can do all of these things. Like, we've heard about 10x developers, those people do exist, but you've got to have some humility and realize, like, April's way better at this than me. So why don't we get April to help out? Like, I don't ever want to own anything end to end. I want to bring in the right people at the right time. And humility is really, really important for that. I think that's one of the things that's the least talked about parts of DevOps is humility and knowing where your expertise ends and knowing when it's time to ask for help. And I think that we don't talk about that enough. And I think that really applies to infrastructure as code as well. Because people will adopt tools in their organization that they know really, really well, but they haven't thought about whether other people can kind of get to grips with them. And I think that's so important.
Or how they play together as well.
Yes.
I had a customer that used 12 or 14 tools across their development stack. And I remember seeing them and talking about Azure DevOps, the product. And I talked about, right, we can do X, Y, and Z. This is how the product works. And they're like, well, how do I do that? How do I do that feature in like Cake? Or how do I do this in Pickle? And I'm like, hold on, you're using 12 different apps. I'm going to show you how you do it in Azure DevOps, because the whole point was having a consolidated tool to deploy any code to any platform. That's what we were talking about that day, and how we can streamline their developer velocity. And they have all these different tools. So, okay, if I'm a developer, I have to learn 12 tools. Like that just adds to my job. The tooling makes it tough. That doesn't help us be more effective as developers. So it's things like that, having that thought through there, and knowing when to say you don't know something. We talk a lot about, oh God, sorry, it's late my time. When you realize whatchamacallit, mentality. Never mind, forgot the word. But when you realize you don't know a lot in that field and you feel like a fraud. What's the word, Suzanne? We talk about it all the time in tech. Imposter syndrome. Thank you. Sorry. We talk about imposter syndrome a lot. And I think when you're working that DevOps mentality, to raise your hand and say, I don't know something, is okay. And it always reminds me, like, you go to customers and you see like that one person's a single point of failure in the organization, and they hold on to that knowledge. And you're like, well, hold on, share that. And then everyone else can learn as well. And it's okay to say, like, I don't know everything. Like, I know this much up to this point, or this is what's documented. But we all have, this imposter syndrome in us, and that's okay. And I think when you learn that there's so much out there to learn, that's when you really start feeling it. You're like, I don't know a lot. And it always freaks me out when people call me an expert in something. I'm like, I don't like that, because there's always someone out there that knows more than I do, without question. Always. Trust me. I'm sure there's like 10 people watching right now. They're like, yeah, I know more than her on Bicep or Terraform. And that's cool. That's absolutely cool.
That's great. And as long as you talk to each other and share and be open to you need to create this safe space where you can work together, but you can also discuss these topics together. And by pretending you know stuff, but you don't, will not make you a better 10x programmer. It will not. Asking questions will. Helping people will. But not be a know-all. These are not the times to have all knowledge about everything, because things just happen too fast. Mm-hmm. It's so fast. I focus on like 2 areas, and I can't keep up.
Yeah,
2 areas, and I'm like, I can't even, And this is true literally for everybody. So don't doubt yourself on that, and try to find each other. And I think that by adopting like infrastructure as code, as an example, adopting DevOps, those are like extremely good situations to start figuring out how do we work together as people. Because like you mentioned, it is the people, working together and how we interact with each other. And these tools, they facilitate us. They facilitate us having those discussions. And for instance, not when you have some incident happening in your production environment, having to gather all kinds of people, which you talk to, maybe during lunch or outside the office, or when you're paintballing or something like that, and figuring out, how does this application, how's the communication going? Well, I'm just responsible for the database. That's not a story you can keep on doing when you embrace these kinds of tools. You have to work together.
Teamwork makes the dream work.
I was just thinking, like, I've never been in a production outage and ever heard anybody say that's not my responsibility. Like, human beings in general, in my experience, the people that you work with, it's very rare that people just go, nope, I'm not doing that. It's nothing to do with me. When people have these incidents and outages, my experience has always been everybody comes together to get the problem solved. And we had a huge internet-wide outage yesterday, and I was really, really impressed that the provider was back up and running within an hour. That to me is an example of what teamwork can do. It's like, I really believe that kind of creating environments where you can ask questions and you can all work together. It just makes us all happier, especially in this weird pandemic world.
I agree. And Lee, also, you used the outage yesterday, which is a very prime example. Because of infrastructure as code, people can recover from incidences faster. So someone asked a question earlier about how you recover, how you manage different environments. They're meant to just be broken down and built back up again. And if I know how long it takes my pipeline to run, when you start talking about backup and disaster recovery and how many hours have you spent in disaster recovery meetings and testing disaster recovery, or lost your entire environment, as I have before, it's meant to be break down and repeat. It's meant to be repeatable code, and there's a way to do that. And there might be some manual processes in there potentially, but when there is an outage, it's that incident response. Are you transparent? How does your team respond? And instead of having an argument in the blame game, saying, right, we know we have all this templated, boom, push out another pipeline, reproduce our environment, or deploy it to another region. So all these things with infrastructure code help you recover from incidences much faster. So that needs to be part of the game plan and a compelling reason for an organization to do it. Because if your disaster recovery plan is, let's say, 24 hours for a DR plan, what if we had that as infrastructure as code and we could deploy that within minutes? Let's say 30 minutes to an hour, like we saw yesterday. That makes a massive difference to organizations and how they perform and the compelling reason why to start looking at infrastructure as code.
Yeah, I think something that we didn't touch on as well is not only does infrastructure code help you recover from these outages, it also gives you that auditability that says, well, this changed at this time, and then we had an outage 1 minute afterwards. That seems like a smoking gun. And again, if you're creating things manually or going into cloud provider consoles and clicking around and creating stuff, and people are able to do that, and that's the kind of practice that you're involved in, who knows who's making changes and what's happening in your environment that could create these problems? How do you ever know what's actually happened? Like, I have personally, one of the first places I go during a production incident is straight to the Git commits of the infrastructure as code repos that we have. Did anybody change anything in the last half an hour?
Red button.
Yes, exactly. And that auditability, I think, is so important when you're, when you kind of adopting these practices. I think again, it's all software development. It's usually Git or GitHub or something along those lines. But at the end of the day, you get all of that kind of ability to be able to say, this changed, and now we have an outage. We can either roll it back, or we can fail forward, or all those kind of things. And it's that goes hand in hand with recoverability and like disaster recovery as well.
Absolutely. It changes the story without question. It's a compelling reason every time, but having that full traceability end to end and monitoring. So A, recognize the outage, then B, be able to trace it, say, right, we know we made an issue here, or we made an error here, let's fix it. But hopefully they get caught early, but things happen, or you have a legit outage. I mean, outages happen, and I think it's how you recover is then that next side of that story as an organization, because the clouds are going to go out. Like, the clouds are going to have rain. They're going to have issues. So either you need, you can either redeploy your infrastructure to another region if possible, or you need to, what's your game plan? What's your game plan when things fail? Because something's going to break.
No provider that I'm aware of offers 100% uptime SLA. That just doesn't exist. So you have to prepare for those moments.
Absolutely.
Yes, which brings me on the topic of SLAs, but we already had the discussion about that. If you want to learn everything about SLOs, please take a look at the past recordings. I think we had a discussion on that 3 weeks back. So thank you, Lee. Thank you, April, for joining me today at our meetup. I hope you had a fun time. I know I did. Yeah, the recording will be online somewhere within the next few days. Please, like I said, do check out our recordings on our website. If you have any questions, be sure to join our Contributing.today Discord server, which is of course always on. So you can hang out there with us. Next week we will be back with a new meetup, and we will discuss Quarkus, and I'm looking forward to that one as well. Great, thank you, and see you next time. This is the moment we do the awkward wave. Bye.
Thank you all.